All right, we'll get started. All right, everyone. Well, thanks for joining us. I've got three experts here who've seen what happens when AI ambitions collide with infrastructure reality. Bryce, Brian, and Victor, give our audience the 30-second introduction about your company and your role, please.
Yeah, so I'll start out. Bryce, Kleen. I work for Vertiv. I assume a lot of you have heard of Vertiv. If you haven't, we're big into the power and cooling infrastructure. Myself and my team are involved with a lot of customer engagements where the question of how do we take this on, this new AI load, how do we take it on, comes to us. So a lot of site surveys, a lot of consultations with customers to figure out how to fit an AI solution into their operation.
Brian Donahue with Eaton. I've been banging around data centers, I guess, 30 plus years now. My main role is helping both internal and external customers with power space and cooling challenges on the white floor space. So Eaton's a massive company, just like Vertiv, but kind of think of me as I'm the guy that sits inside the four walls all day, and I specialize on the white floor space.
Victor Avelar from Schneider Electric / APC. Most people know us by APC. Acquired in 2007. I've been working on a small research team called the Data Center Research and Strategy Team. And our entire role is to understand data centers, research, do some analysis, whatever it takes to help customers make decisions when it comes to moving their data center projects forward. So our main output's white papers and these things called trade-off tools. You may have heard of them. But that's what we do.
Excellent. Thank you, guys. So before we dive in a little bit deeper, we use this cool thing, Slido. If you haven't been using it all day, there's a QR code over there. So our quick poll question to see where our audience stands with regards to their current experience with AI workloads in their data center. Selections include planning our first AI implementation, running a pilot test AI workloads under 10 kilowatt per rack, production AI workloads with some infrastructure challenges, full-scale AI deployment with retrofitted infrastructure, or built new infrastructure specifically for AI workloads. Give it some time. Give it about 5 more seconds for folks to fill in their answer. Man, I can't see that at all. So you guys tell me what it looks like.
So first one, 57%. Second one, here we go.
Oh, wow, that's a lot bigger. Okay. I did not know that's how that works. So good amount planning our first AI implementation. That's pretty cool. We got 38% on production AI workloads with some infrastructure challenges. Cool. And running pilot test AI workloads under 10 kilowatt per rack. I find that pretty often with my customers. They're having difficulty having that dense power within their rack space. A few of my customers came to me asking, hey, can I get an AI solution in 8 kilowatt per rack? Yeah, it's very difficult and possible, really. So going into Victor, you analyze data centers for a living. Looking at our poll results, which now I accidentally advanced the slide. Looking at our poll results, what's the biggest gap between what organizations think they need for AI and what they actually discover they need?
I've been hearing a very common disconnect. So I'm going to go with when people say, I want an AI-based server, there's GPUs in there, there's usually 8. And they typically are surprised when we tell them, OK, a single server can draw 12 kilowatts or 15 kilowatts. There was even a case where a customer bought 3 or 4 of these NVIDIA servers, and they were able to plug 2 of them in, just because they didn't have enough power in the data center. So that's a big disconnect. And then, of course, if you don't have the power capacity, you don't have the cooling capacity.
Mm-hmm. Yeah, I mean, one of our deployments that we did for one of our customers, they asked us to slowly turn on each one of the DGXs because they were worried that they were going to trip a breaker or cause a blow up. And then even to the point of the sound that they produce It even created someone to run into the data center and say, shut that off, it's too loud. And not understanding that, yeah, you bought a DGX, it's pretty loud. Except for the new 7745, which if you haven't heard it, it's like ear piercing. Since the new RTX Pro 6000s, the server editions don't have a fan on the actual card, that the actual server needs to ramp up its fans to cool down those. So really, really interesting for sure. So Bryce, I know you guys at Vertiv get emergency calls. What does that conversation sound like when someone realizes their air cooling just isn't going to cut it?
Yeah, that's a pretty common question, or pretty common call that we take. The first question I always ask is, do you have chilled water available? If they do or they don't, that doesn't mean the game is over, or that they have to go down a certain path. But that's a good first step. Do you have chilled water available? And can you chill things, or can you cool things can you tap into that loop? There's a lot of other options that people have. There's liquid to air solutions, so we call those like an AI starter kit. So if you don't have liquid, you can still get started, and you can take advantage of some existing air cooling that's in the data center. And there's also refrigerant-based systems. So there's a lot of different ways that you can deploy liquid-cooled loads. Sometimes though, we'll get the call from a customer and they'll say, I want to fit it in this data center, and you just have to kind of have that discussion that you're going to spend more money trying to retrofit this operation than you are if you were to maybe look at a modular solution or something like that. So modular has become almost every conversation has some element of modular discussion built into it.
Excellent. It's cool that you bring up the liquid to air, like even self-contained, right? Like even for consumer PCs, if anyone in the audience has ever built their own PC, you understand the AIO, or all-in-one liquid cooling solution, right? It's super cool to be able to see that come into the servers and introduce the first liquid cooling into what they're trying to deploy for infrastructure. So Brian, from the power side, what's the most common mistake you see when people are trying to retrofit for AI workloads?
It's really going to parallel what these two folks are saying. Probably the biggest misconception is it's coming down from the C-level suites. The guys just don't really understand what an AI deployment looks like. They think of it more as almost like a software upgrade, like just an application that you're just going to plug into the environment. And these systems are just exponentially, more power hungry. They're more dense. You need cooling, as Bryce was saying. So that misconception of just how quickly these guys can turn these systems on, and the fact that they don't then do the proper site prep, right? They just want to go out, deploy the AI application, not understanding that it literally touches and changes everything in the data center. I would say that is the number one thing that I'm dealing with. Once we get past it, but it's a painful conversation up front.
Absolutely. I've had those conversations. All right, diving into our second poll question. This brings up a critical decision point for everyone that they face, right? What's the primary cooling strategy for high-density AI workloads? Traditional air cooling, hoping for the best. Enhanced air cooling with containment, like hot aisle containment or cold aisle containment. Hybrid air to liquid cooling solution, what we just discussed. And direct-to-chip liquid cooling. And the last one, still evaluating options. Send some help. Give this one 10 seconds. Looks like we're also doing good on time. Now I'm assuming our little monitor here is going to change. There we go, very cool. So traditional air cooling, hoping for the best. Definitely the typical what I see with my customers. Still evaluating options, send some help. Yeah, well, definitely reach out to your AE, and then I can definitely have a conversation with you or someone from our team. We just had a tie right here. Hybrid air liquid cooling solution. Very cool. So assuming possibly vertical heat exchangers with air on the server, and then possibly that on the back end. Very cool. So here's something. All right, that's good. Here's something that I'm curious about. So Victor, when organization retrofit for AI, it's not just a technical project, right? You're dealing with the facilities teams, IT teams, sometimes construction. How does that get complicated?
If it's an air-cooled server deployment, yes, it's still high density. You still need the power distribution. But it's less of an issue, right? Everyone's comfortable with air-cooled servers. We've been deploying them for decades. It's when it becomes a liquid-cooled server that it becomes more of an issue. Why is it an issue? Because the air gets to the server without like a pipe, right? Maybe a duct if you have hot aisle containment. With a liquid-cooled server, I call it close-coupled. You literally have a pipe connecting your cooling system to your server. That, by definition, means that you're involving a bunch of different people, and there's no clear delineation. Who owns the piping? Who owns the server? So that causes some angst. For example, warranty, server warranty. Whose fault is it if you have multiple models on the same loop and one of the servers gets clogged with particulate? Is that the contractor's fault? Is it facilities? Is it the IT person who didn't do something correct in their procedure? So it's not insurmountable. I mean, we're going to solve these issues as an industry as we get more standards and more experience, but that is something that you need your whole ecosystem of partners involved, including your IT vendor, just to make sure that they're getting the right temperature water, the right flow, the right purity of that water going through their server, and that you just sleep easy at night, because this is a major investment, obviously.
For sure. I mean, one of the things that we definitely learned after deploying 3 different liquid cooling solutions in our AI lab was ensuring that every person is on the same page. If person A knows more information than person C, there's going to be an information loss between them causing issues, right? And of course, coming to SHI for us to help you with any issues that you may come across, because we most likely have done it or had the issue and overcame it. So Bryce, when you're implementing a liquid cooling, someone has to take responsibility for potential leaks. How do those conversations go?
Yeah, it would be great to think that we're not going to have any mistakes and any failures or anything like that. But unfortunately, we live in an imperfect world. Everything is really overbuilt, so the connections are industrial grade connections. But the reality is, at some point, someone, and we've seen it already, someone's going to have a few leaks. Mm-hmm. So there's a lot of things that play into that. One, we have to look at worker safety. So we have to make sure that we have something that's going to automatically shut down the power to that rack where there's a potential leak. We also have to look at protecting the servers. And unfortunately, if you starve a server of liquid for more than a couple seconds, it's going to go into thermal shutdown. So all this stuff has to be automated. And there's a lot of different approaches to it right now. We see a system, and I put that in quotes because a system could be 2 or 3 different applications talking to each other. And that's always a challenge. That's something that you have to look at when you're going into this is, okay, who's going to have the ultimate control? How do I make sure that I have a graceful shutdown for my IT load? How do I make sure that I close those valves off? How do I make sure that, if I see a leak in a rack, is that a slow leak or a fast leak? We have to have a lot of different monitoring points to be able to make those intelligent decisions. And all that has to feed into one central decision-making tree, and then instant commands go out from there. So it's something that really needs to be looked at closely when you implement this. For sure.
And when we did our liquid cooling deployment, we had leaks. There will be leaks, and you have to prepare for it, 100%. So Brian, power upgrades usually require outages. How do you sell leadership on taking systems offline for infrastructure nobody sees?
Good luck with that one. They're laughing. One of the biggest challenges that we run into is if you go back to that first question, right, with the C-level guys, right? So everybody in the room right now is already under a tremendous amount of pressure to get these AI deployments off and going, right? When you combine that with the fact that you now want to go up to that C-level suite and say, not only are we 6 months behind on this deployment, but now we want to actually take other applications offline so that we can create space to bring these new applications on board. It's a very unpopular conversation. So what we're mostly seeing is folks trying to take what they have right now, pull as much power to the racks as possible. So that's first thing. Second thing they start doing in parallel is going, after we all tell them you can't plug it in here, they start looking for other places to plug things in, whether that's colo or service and something like that. And then what some of the older guys are doing, right, that have been around and have the gray hair like me, they start looking at, okay, where can we take applications and parallel or mirror them someplace else to create space, create a vacuum, right? So we can go back in and fix up those rooms. But what gets crazy on all of this stuff is when you look at trying to deploy into an existing facility, for example, like we just did one last week where just to set up just two, right? Just two small little little AI racks, we had to pull 16 power whips into just two cabinets. And it sounds insane, but that's what the building had available. So that's what we had to do, but it wasn't optimal. The great thing is the person who was saying for 3 years we're not upgrading the facility, once he saw that, was like, hey, how soon can you upgrade the facility? So a lot of times you almost have to live through it once for them to really start to understand just how invasive that process is.
It's really interesting you bring up the amount of PDUs for the recent deployment. A lot of times when I'm building the bill of materials for my customers and I'm explaining, well, you're deploying a DGX B200. The new B200 requires either one PDU or 6 PDUs, since there's 6 power supplies on the actual server itself. And since it's no longer an N+2 redundancy, it's now N+1, your typical 2 PDU rack is actually going to cause more harm than good. So having 6 PDUs inside one rack and then splitting it across if you have multiple DGXs getting deployed, they're like, that's insane. I had to have a full conversation with facilities at a colo, since that was their first AI deployment, explaining to them, yes, this is our standard now, and you're going to have to figure that out. Even back to my point with my customer that has only 8 kilowatts per rack, started telling them you're going to have to bring more circuits per rack if that's all you have.
Yeah.
Because it's just not enough for an AI deployment.
And Austin, like as crazy as it sounds, like we just launched a cabinet. It's 54 inches deep, 32 inches wide, holds 5,000 pounds.
Yep.
5,000 pound rack for IT gear. That used to hold a lead acid battery, right? Yeah. So the point is, we have IT racks out there that weigh as much as a pickup truck.
Yeah.
I mean, it just is what it is.
Yeah, and it absolutely, going back to that point, you know, it's 6 PDUs in a typical rack. Like a lot of times customers, they're standardized on only the 300 millimeter wide, right? Or 600 millimeter, whatever the case may be. They're not able to actually fit the rest of the cables and the depth that they need to fit all of those PDUs inside that rack. And that's something that I have a conversation with my customers almost every time.
Yep.
It's a fun conversation. It's like second nature now.
Yeah.
So to Victor, if someone comes to you tomorrow and says, we need to implement AI workloads in our existing data center, what's the first thing they should actually do?
Yeah, so I kind of alluded to it already. You need to go out there and find out how much spare capacity you have in terms of power and cooling. If you don't have enough power capacity, chances are you're not going to have enough cooling capacity. So then you're really limited at that point. Now maybe you can do virtualization and consolidate and free up some power, like Brian was saying. But ultimately, you need to know what you have right now and then decide, is that enough or not? And then you have to go back to your IT folks and say, what are you telling me I need? Do you need 2 racks of 20 kilowatts apiece, or do you need to put everything in one rack? By the way, you just don't make the choice to split up the racks into multiple racks. There's a penalty you pay in terms of the GPU communication. That's why we're seeing these high density racks. We're not trying to like break the world record for the highest density rack here. There are reasons why you need to put all the GPUs together in a single rack, and it has to do with the communication between the GPUs. So don't get this idea that I'll just divvy up the racks. You can't do that.
Excellent. All right, over to Bryce. From a cooling perspective, what's the one question they should ask that they probably won't think to ask?
Yeah, I would say probably the first question you need to ask when you're considering liquid cooling is, what is my air cooling load, my air cooling heat load? I think there's a bit of a misconception that once we go liquid cooling, we can, there's a net zero or room neutral. But typically a server is only going to be able to pull off about between 70 and 90% of its heat from the direct to chip connection from the cold plate. And so you end up with 30 to 10% of the total load still having to be cooled by perimeter cooling or in-row cooling or rear door or something like that. And again, that might not sound like a whole lot, but when you're looking at racks that are 130 or 200 kilowatts, or people are talking about megawatt racks, that's a lot of heat to be able to deal with via just the air process. So it's pretty important to understand that, because a lot of times your net air cooling load is actually going to increase by adding liquid cooling, which sounds weird.
Yeah, for sure. I mean, even with, you mentioned the megawatt of power, that is NVIDIA's inevitable goal, is to have 1 megawatt of power inside one rack. Right now, their NVL72 solution is water-cooled, well, liquid-cooled, and also air-assisted as well, because not every single component is liquid-cooled. Their future with Vera Rubin is going to be completely liquid-cooled. And if anybody did some tours and experiences yesterday, you probably heard me explain the architecture, how they took it from stacking servers on top of each other to now taking it sideways and even adding more GPUs. And then for some reason they decided, let's put a motherboard directly in the center of this contraption, right, which limits airflow. So in the future with the Vera Rubin NVL72s, they're going to be completely liquid cooled. So really interesting future we're going into for sure. So this seems like the last question here. Brian, power-wise, what's the hidden gotcha that catches people off guard?
Would everything be an inappropriate answer? I think one of the things that I see a lot of people struggling right now is going back to what they're both talking about here is just cooling in general, right? And you go, well, that was a power question. What's cooling have to do with it? Well, one of the things we're getting more and more questions on these days is CDUs and putting CDUs on UPSs, putting the entire mechanical system now on a completely separate power system. And the reason being is pumps and motors really don't like UPSs very much. And so one of the things we're running into is these CDUs now are, it's almost like you were saying, within a few seconds, right, those servers are going to drop, right? Well, that CDU now was like a piece of IT gear, right? So it needs to be protected. Mm-hmm. The challenge is when you start trying to pile all that stuff onto your existing power infrastructure, you're usually going to go past what it is. So now guys are asking, well, if we're going to upgrade the system, should we just take all this and set it aside? So funny little side story is, so that person we were doing those 16 power whips with, right? For them to even set that up, because they were at a colo, they first had to bring cooling into that cage. Just the cooling loop alone was $1.5 million. Mm-hmm. So there's two. Yep. I know you asked me for one, but there's
I like expanding to multiple answers. I appreciate that for sure. Well, we still have some time left, but this definitely has been incredibly practical. Looking at our poll results, it's clear we have multiple people at different stages of their journey, and that's exactly what I see with multiple of my customers. So at SHI, we of course meet our customers where they're at and help them out in figuring out exactly where they need to go and how they need to do it, and helping build that solution, right? So, well, I think the biggest takeaway is that accessible AI infrastructure isn't about having the newest technology, but about honestly assessing what you have, understanding what you actually need, and building a realistic path between the two. I truly thank you, Bryce, Brian, and Victor, for your insights and coming here and saying yes when I emailed you, hey, do you want to be a part of a poll? I'm sorry, not a poll, part of a panel. So whether you were voluntold to do it, whatever it may be, I definitely appreciate it. But before we wrap up, for folks who want to dig deeper into the specific infrastructure challenges, whether you're in that planning group dealing with the real-world deployment issues, or you can contact your account executive and connect you with myself, my team, or any one of our AI Pursuit teams. And you can use that QR code right there to be able to fill out that information. So thank you so much, and join me in thanking our wonderful panelists.
Thanks, guys. Appreciate it.